Climate change is happening, but what can we do more than reduce, reuse, recycle, or reducing greenhouse gas emissions? Well, what if I told you that we could actually cool the Earth's climate by solar radiation management? Well, before we get onto that, we need to understand how much radiation that the Earth is receiving from the sun. About 50% of solar radiation is actually absorbed by Earth's surface, 22% absorbed by atmosphere and clouds, 3% reflected from Earth's surface, 20% reflected by clouds, and 5% reflected by the atmosphere. And together, only 50% is reflected. While our current solar radiation is happening, we do have increasing human development as well as global warming and temperatures rising every year, which leads to ice caps melting, ocean temperatures rising, and since ocean temperatures are rising, we do have more water, which also equals to low albedo, which then leads us to greenhouse gas effect occurring, heat absorption increasing due to more water, which leads back to global warming and temperatures rising, along with our increasing human development. And thus, we have our positive feedback loop. However, let's go to our term called albedo. Albedo is a measure of Earth's reflectivity. So low albedo equals less reflection, more absorption, more heat. Whereas high albedo equals more reflection, less absorption, less heat. As we can see from our charts, we can actually see that our highest albedos actually occur with snow and clouds, where in contrast, water and any dark covered forests such as coniferous forests actually have low albedo. As illustrated in this map here, you can see that our darkest areas of albedo actually occur in our northern hemisphere, where there are actually more ice covers. Obviously, snow and ice do reflect solar radiation very well. However, we can't have a snow-covered planet. So how do we increase albedo to mitigate climate change? Well, our current solution is climate engineering. Climate engineering does seek to increase Earth's albedo by inputting aerosols in the stratosphere, cloud seeding, and by increasing the amount of reflective, or white, surfaces in urban areas. With aerosols, we inject sulfur dioxide aerosols into the stratosphere. These aerosols actually help scatter and reflect solar radiation. This method can be done by sending aircrafts or balloons into the stratosphere. Also, these aerosols actually mimic stratospheric sulfate deposits from volcanic eruptions. And did you know in 1991, Mount Pinatubo in Philippines, the eruption produced 17 million tons of sulfur dioxide and cooled the northern hemisphere by 0.6 degrees Celsius for 2 years. And if that's the case, sulfate aerosols can cool global climate over a span of years, which means artificial stratospheric injection is only periodic. Thus, it is cost-effective and timely. Cloud seeding uses silver iodide to provide nuclei due to its similarity to ice crystals. An increase of clouds increases reflective cover, so it is increasing albedo. Luckily, it does not contaminate the environment. Only trace amounts leach into the environment and are not harmful enough. Now, cloud seeding has been implemented in California for the past 6 decades. Maybe we should learn a couple of things from California. And finally, reflective surfaces. Reflective surfaces actually help solar radiation management on a small yet hands-on scale, and it's easy for citizens to implement. White paint is a highly reflective surface in comparison to many other colors. In metropolitan areas, urban buildings can be painted with white paint. It is also much more effective in warmer climates. White paint actually reflects solar radiation while keeping buildings cool. It also indirectly helps reduce greenhouse gas emissions due to the reduced use of air conditioning. And as quoted by the California Energy Commission, if all urban flat roofs in warm climates were whitened, the resulting 10% increase in global reflectivity would offset the warming effect of 24 gigatons of greenhouse gas emissions, or equivalent to taking 300 million cars off the road for 20 years. So why is increasing albedo important for Earth? Don't we have enough climate change solutions? Solar radiation management projects will help supplement our previous and current climate change solutions. Our current solutions are, indeed, mitigating climate change. But human development and global temperatures are increasing at an exponential rate that current solutions are not able to keep up.